Okay, now I'm going to construct what we call a power function graph. Now, it has to be proven, and we haven't proven it, but it is easy enough to prove that if we have a function that's a standard definition power function, a standard definition basic power function, and I can write the form of that function. It's f of x equals x to the p. So y equals f of x, which is x to the p, for some number p. That's your basic power function. Now, generalized power functions and deal with that, but a basic power function has this property. And if it has this property, then this condition holds. There's some y factor such that the y value always changes by that factor whenever x doubles. And conversely, if the function, or if you construct a graph by this rule, it will be the graph of some power function, and which power function is determined by the y factor. So the y factor determines p, and p determines the y factor, and there's a pretty simple relationship between the two, which, however, you kind of need to understand logarithms, and I'm not assuming that at this point, although it might well be the case, to really understand that relationship. So right now, we are just trying to do a geometric construction to give us a graph of a power function. Okay, so what do we have here? Y changes by a certain y factor whenever x doubles. Okay, I want to construct a graph for y factor three halves. Now, first thing I'm going to need, we have some condition that holds whenever x doubles. It's going to be very helpful to me if I have a series of x values that each of which doubles the preceding. So I can easily do that. I can take some very small x value here. Okay, then I can take my compass and I can, at least theoretically, and in practical terms this could be a bit of a problem, I can double this distance. It's going to put me right there. I know which chalk molecule I'm looking at. Okay, and there I've got a doubling. And then I can set the compass to that distance and move over, or I could just set it here and flip the compass, but I'm not at a good angle to do that, and I can mark this point. Okay, then I can set the compass again and mark a new point. And the compass is not going to stretch that far, but I'll pretend I've got a compass, and I'm going to say, okay, well, we got to have this distance, so we go this distance here, and then I want this distance, and that's as far as this compass is going to go, but that's as far as we can go on our graph. So here is a series of doubling x values. Now, another way to get a series of doubling x values, if we know how far we want to go on the x-axis, we could specify a point here, and then we could bisect the interval between the origin and that point, and then we could bisect the interval between the origin and that point. So had we specified this point, when we bisected, we would have gotten here. When we bisected that, we would have gotten this point, etc., 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 until we get so close that we can't construct the bisecting. Okay? So there we have it. Series of doubling x values. Okay, now we can begin constructing our graph just by taking this very first y value and our first x value and marking some value that's going to correspond to the value of y. So I'll kind of project that value over to the x-axis. Right here is our first y value. Okay, we've got to double that y value. Well, yeah, I can start off with a compass. Okay, I can double that y value, and that puts me, well, I don't want to double the y value. I want to increase the y value by, or change the y value by factor 3/2. So I started to double the y value. That was a little ignorant, but I can construct, if this y value is big enough, I can construct the bisector of the segment between here and here. The doubled y value would be up here. I'm not going to try to construct that, it's just too close. But right there would be the new y value, and that would be the y value of the point that you get when x doubles. That would be the y value for this point here. So I can project over and up, and I've got a new y value and a new point on the graph. Okay, then I can bisect that y value, and maybe I get something like this, and I can add that here, and as I say, I'm not going to actually try to do the construction. Okay, it would take too long, but you know how to do the construction. You could do this. And then I continue doing so. So let's see, if I bisect that y value, it's going to be about this big, and add it to this, I'm going to get that. And that's going to give me a point about here. I project over here, I get this. And then I bisect this value, maybe I get something like this. I add this much, gives me a point over here. And I've got a curve that I can continue. And if I continued it right, this value should be half again this value. Okay, so my y values are increasing by factor 3/2. My x values are doubling. Now you see that we're just using what we already know we can do with constructions, which is constructing segments that are 3/2 as long as a given segment. That's the first factor that we use. Now, what if we wanted to do a bigger y factor? Now, what if we wanted our y factor to be, let's say, 5/2? Well, I can start with the same point here. So I can use this first point that we used on the 3/2 graph, but now I'm going to have to double this and then add half. So I've got to take this, do it again, and add half, and that's probably going to get me up to about here for the second point. Then if I double this and add half of it, that's going to probably put me up about here. That's going to be above this point. Okay. And so forth. Okay, double this gets me up here, and I'm going to go up pretty high, so I'm going to end up with a pretty skinny graph. And I'm not sure exactly what that graph is going to look like. Well, I don't want a really skinny graph. I'm going to make a fatter graph. And this time what I'm going to do is I'm going to get tricky on you. I'm going to construct a graph with y factor 5/2, but I'm going to start out here. Okay? Now, between here and here, well, my y value here has to be the y value such that when I multiply it by 5/2, I get this. Well, I know this value. How am I going to find this value? Think about that. You should be able to come up with an answer very quickly. A lot of people do. Well, if this is 5/2 of this, then this has to be 2/5 of this. I can't construct 2/5. So I'm going to eyeball estimate 2/5. It's a little less than half. So let's say here's half. So 2/5 would be about here. So that's going to be a point maybe here. Then I come down here. There's half. About 2/5 would be here. And I come over to here. And then 2/5 of this would be about here. And 2/5 of this would be about here. 2/5 of that would be about here. And now I get a graph that looks something like this. But that graph wasn't constructed. I eyeballed that and estimated it. Well, I can use that graph to give me a reasonable starting point. Let's say that I say, okay, this point is going to be on my graph, and now I'm going to construct 5 halves based on this point rather than on this point here. So, now I'm just going to do it with my fingers. I double and then add half, and that gets me up to about here, I think. Oh, wait a minute now. No, double that, double, add half. I'm sorry, I went too high. That gets me to a point here, a little higher than the one I had. And then I'm going to double that, and add half. Well, three times would be there, half again would be there. So that's going to give me a point about here. Then I take this, double it, and then add half of that. That's going to get me to a point that's up here a little higher. Okay, so now I'm going to construct a darker orange line. That is actually constructed rather than eyeballed. So my eyeballing didn't do too badly, but I didn't quite have